Testing audio. 1, 2, 3. Okay, sounds okay to me. Welcome to the stream of the Discourager of Hesitancy, where we are working on compilers today. We're still in the Tokenizer generator. We're going to be here for a while. I find the Tokenizer generator to be the most interesting piece currently. So we're going to hang out there. And we're going to wait for a few minutes for people to roll in before I reveal how I cheated. And while we're doing that, I'm going to open up a fresh Emacs, I guess. Oh, come on. Yes, kill everything, pop up a new Emacs. Okay. We'll do the same thing like that. So we will size for streaming, which should be a lot more readable. And we're going to go ahead and open up our project documents. So to-do. And our journal. Okay. So here we are. And then time to get the old beverage of choice ready for the day. And I've basically narrowed my company name down to 2 options. I think no bones about it, Game Studio, or Last Penny Game Studio. Either one would be reasonably useful, easy to logo up, good to go. But this is our day off. This is our variety day, compiler day. I feel like it's hard to get traction and momentum with this project because we only do it one day a week. Okay. Ooh. Okay. And if that's the case, let's set up our journal for the day. Which doesn't take long. I think that's about it, really. It's about as far as I can stall out my entry. Okay, all right. So last time, we failed to generate an iterator inside of our TxtBuffer implementation. So that makes me sad. We did generate a parser context, which right now is somewhat minimal, That's okay because we already have plans to expand on it. We are generating a token. This is the important piece that's going to be the majority of our concern for a while. Then we're going to start generating the tokenizer. Kind of got to start on that, but where we ended up with is that we have so many different pieces of code that we're flinging about. It's actually crowding us out quite a bit. And this is where I cheated. I usually don't develop on stream if I can avoid it. I don't avoid off-stream development. There we go. I don't know if I said that correctly. But I did because this task was too good to not have it done. And instead of spending an entire stream doing it, thereby slowing down other tasks, I went ahead and did that over the weekend. So we now have an asset pipeline for our compiler, well, for our tokenizer generator. Let's go take a look at that. We have tools. We have a class called embed code snippets. What it does, where are we? Is we load in a bunch of snippets from some location. Which looks like this. And we have a key, which will be used by the build project. Then we have a file name. For now, all the keys match the file names. They don't have to. And then this guy emits two files. One is the code snippets HPP and the code snippets CPP. Look at that, code snippets H. It puts it all inside of a namespace, and we have for every file. So let's go look at the VV proj parser. So let's go to assets, code snippets, VV project parser .h. And what you'll see is I have a little bit of templating I put in. If I put backticks around, it'll find that key, and then we should pass it in. So blah blah blah, and then you see this ... Basically, it takes this one snippet and it cuts it into parts, and the ... is where I emit my code. So I'll say emit VV proj parser section 1, then I'll do things, and then you emit part 2. So if you look at this thing, you'll see the VV proj parser HPP has 2 segments. And these are just a way for me to look up the code snippet. And we can also get the name of the code snippet. So if we look up code snippets.cpp, you'll see that we have the name for each one. Oh, oops. We do not have the dot here. That's awkward. I wonder why those don't have dots. But it's fine, it's fine. We'll figure that out. It's not really important, I'm not really using this. And then here are the code snippets. It's just an array of string literals. And that's it. I mean, it's really no more complicated than that. Cheats, yes. So now, instead of fighting the string type stuff, we can just write our code, put in any templating we need, and break files into fragments where it's like, here's all the boilerplate, here's where I'm going to emit code, here's a boilerplate, here's where I do code, with a ... That is way better. I think. Although was generated. I think that's better. VV. That's fine. Whatever. So that's my cheat. We now have the entire code snippets thing outside of our actual code file. So we're like, if we go to VV proj, let's see, where are we? Source VV project. We no longer have a writing at all. Rather, it's all much more succinct. Where right. Okay, so we get our two files. There's our header file, there's our CPP file. And you can see it writes out a code snippet, which I can look up, and here's the template that we pass in to replace things. And that's it. And then we write out our specific code, right? This is where the ... was. And here's part 2 that we emit. CPP, very similar, right? Here's our part 1 of our project parser CPP file. Then we write out our, which one is that? Oh, and this is the other thing we did. We write out something, we write out our character reference, our string reference. We write out our text buffer, our context, and then we emit some special code. But yeah, everything else in here is basically, like, here's the right character reference. Depending on what our encoding is, we grab a different snippet. Same thing for the string reference. Token HPP. So this is the token snippet for the header file. And here's the token snippet for the rest of it. And in between, we actually write the token names that are in our project. Okay, so I can go look at that. Source, let's go to assets, token, HPP. There's the ... that we're filling in here. Same thing for the token CPP. We do write a snippet, then we emit the names of all of our tokens in an array, and then another snippet. So this compresses our code quite a lot. A lot. And I'm liking it. This feels so much better. So that's my cheat. I'm a cheater. I did coding off stream, but it is so much better. Once that was done, it actually became a lot easier to do the other thing we tried to do in there last time. We started making an iterator for TxtBuffer. We had a circular dependency where, let's see, let's go scratch buffer, where we had a character reference which references a text buffer in its constructor, right? But then we also had, so we have to declare that below the text buffer. The text buffer, if we put in an iterator, the thing the iterator would do is it'd create a character reference, because that's how we were going to walk through the text buffer. The character reference is our iterator. So we have a circular dependency here where our text buffer iterator needs a character reference, and our character reference needs a text buffer. And forward declaring doesn't work unless we want to use pointers to character references. And if, yeah. So forward declaration isn't going to work very well. So what I did, once I could see things, was I made a text buffer implementation, which is equal to what we used to call our text buffer. Like that's, we just literally copied it. And then text buffer contains an iterator, which is a character reference, and it contains a TxtBuff impl. And a character reference doesn't get a TxtBuff, it gets a TxtBuff implementation, which means there's no more circular dependency. This thing doesn't need character reference, but this thing, so this thing contains both the texture buffer implementation and the character reference. Everything implemented here is made available here. It's literally just a wrapper class to break the dependency order. That's it. So we now have in our VB source, what did I call it? It was VB test product parser. And we now have TxtBuff implementation, which looks exactly like before. Then we have the character reference, which looks exactly like it did before. It is a long one. Our string reference, and then actually the text buffer literally just delegates everything to the, there's the iterator, and then text buffer implements the iterator, begin, end, then all the things from the implementation class, which it composes. So that's it. Everything else is basically as you saw. So just a little bit of reordering. What this gets me is test.cpp. We can now do iterators like that, which is one of the two things we're going to test performance-wise towards the end of the project. So there you go. Those are the two things I did off stream. Now you're all caught up. You know everything I know, and we're good to go, hopefully. So let's go ahead and just take a look at this. Do a full clean and test. There it's embedding all the snippets in my code snippet file. Builds, then it builds the test.cpp. Source builds debug, VB test parser.exe, and it iterates over that text right here. So there you go. We have iterators and we have code snippets. Much cleaner. I think it's better. And well worth it. Heck yeah. Okay. So with that all done, go back to ye old journal. What we need to do today. Okay, let's go back to our sketch buffer. One thing we're going to do in this project is we're going to pound to find choices that might have performance impact. Okay. So one of them you've already seen. So let's go back to TxtBuff. Oh, let's see. Let's go back to this one. Here we are. This one has one in here. It has three different methods to read and open a file. So after we emit this file, we can build this with three different options and see whether open, this is the system call open, the fopen, which is a library call, or if modern fstream, which one reads the file faster. So we're going to do this in a lot of different places. Now that we have text buffer iteration, we can either use the iterator versus a bare character reference in a for or a while loop, right? Okay, that's one thing we need to have broken out. Then in the tokenizer, we need two different options one for lazy tokens versus batch tokens. Another thing in the tokenizer will be switch. Let's see, what am I calling this? State dispatch. We want to implement a switch versus a function pointer array versus gotos. And each of these is going to have a pair, each entry here will have its own pound define. And we will emit code for every combination. So hopefully that gives you an idea. We're going to be emitting a ton of code because this will cross over every aspect of the tokenizer, and that's just a few simple ones I've thought of early on. Because one thing I don't want to get into is the habit of this is faster and never measure it, right? A lot of people make assertions about code speed and code performance without really knowing if it's the case. Until you measure it, you don't know. And your code rarely behaves in the way you expect. The hotspots, you need to measure it. So we're going to implement our code in every way, and then we'll measure. And maybe what we find out is that the for each is exactly the same as the for while performance-wise, or within acceptable parameters, right? If it takes 5 milliseconds longer, maybe who cares? Maybe this doesn't behave the way I expect. I expect gotos to be faster. I expect this to be next faster, and I expect the switch dispatch to be the slowest. Expect does not mean I'm right. So we're going to try them all. We're going to emit a ton of code throughout this project, which is one of the reasons I kind of not froze up last week, but didn't get as far as I wanted. Like, this is in the back of my mind, and then the code snippets. It was clear that my file of code bits was getting too big and too hard to track through. So let's add ourselves a note. Off stream implemented an asset pipeline for code snippets. They live in a asset directory. There is an asset listing that is parsed to well, I guess there's not much to add to that, is there? There's an asset listing. Each code snippet file can contain keys in backticks, which will be looked up and replaced as needed when emitting code snippet. Maybe we each code snippet can be separated into segments with a line dot. So we can output a chunk then emit custom code, then emit the next chunk, etc. Or add infinitum. That's always a fun one. I don't use it nearly often enough. Ad infinitum. It feels good to say. Okay. Also off stream implemented for each iterator in TxtBuff. Wrote the circular dependency. Wow. By having TxtBuff and ChrRef depend on TxtBuff impl. So those are the notes. That's how I cheated. Let's see here. Cheating alert. There we go. Hey, Travest, good afternoon. I am doing well today. How are you doing? Fit Rider, I've got a bit of waving. Good. Howdy, howdy. It's showing up in the chat. So, the reason I felt it was okay to do these off stream is these are the tedious parts that are blocking us from progressing on the actual tokenization task, right? And that will make future development faster. So developing an asset pipeline isn't the interesting part of the problem, in my opinion. And factoring out the text buffer implementation from the text buffer to break a circular dependency, it's not the interesting part. So cheating alert, end cheating. There we go. So anything after that is on stream. So here we go. Oh, one other thing I thought of. Tokenizer. One thing is helper functions like munch. I forget what they're called. We had a few of them, so let's close up real quick. VV assets. Code snippets. Tokenizer. We have helper functions like start new token, new line, and munch. New line, start new token, etc. as functions. Functions versus macros. So inside of our loop, these things are going to be called a ton. This will be called for every character. This will be called for every line. This will be called for every token. So these are going to happen a lot. There is a small amount of function overhead for each one, and we're going to have more of these as we go. So the question is this in tight enough of a loop that replacing these functions, which are very simple, right? This is not complicated. Replacing such small things with a text replacement macro. There is the inline keyword, but it is not guaranteed to ever actually be implemented. It's a recommendation to the compiler, not a requirement on the compiler. Let's see, Fit Rider. I had a non-technical interview today. I was nervous, so I made me stutter a bit. Anxiety is rough, you know? And interviews are so asymmetrical. They can be very stressful. But you got through it. How did it go, other than the nervousness? Your main goal in a non-technical is to make sure that you don't sound like a psychopath, and that you have some general social graces. Like, they're not gonna hire you if you sound insane. And then make sure that you have some general business ethics awareness. That's mostly what non-technical are about. Also kind of shy. Yeah. I'm with you. Like, maybe not shy. I'm not shy. I am introverted. Cultural fit. Yes. Cultural fit. That's what I was looking for. Thank you, JTL. I'm not shy, but I am introverted. Like, being around lots of people makes me exhausted. It just tires me out. Except for family. For some reason, family doesn't seem to do that. Yeah, see, I don't have as much of the social anxiety. Obviously, it's a little bit different going into an interview. That's a different kind of anxiety, and I do experience that. But yeah, well, there's only one thing to do, as far as I can tell from all the literature. There's only one thing you can do that'll fix not being shy, but the social anxiety part, and that is practice. So there's a branch of psychology, and I forget all the terms, blah, blah, blah. But it's basically you start small and acclimatize to the new level of exposure to the thing, right? So, for example, there's let's say you have an irrational fear of spiders, right? And so what the psychologist will do, if they're a good one, instead of prescribing you drugs or whatever, or giving doctor's notes that you don't have to go to class because they're going to have a spider in class, you instead show them pictures of spiders. And that's very anxiety inducing, but you breathe, and then when it starts getting tough, they put the pictures away. But you get used to looking at pictures of spiders, right? And then you eventually move to, here's a real spider, but it's inside of a glass cage. It's not going anywhere, can't get anywhere. You have to be in the same room with it. You don't have to be on the same side of the room, but in the same room. And then over time, you then move them to spending time at the same table with the spider in the cage, until you've eventually worked them up to, here's a tarantula, hold it in your hand. And what happens is your brain rewires itself due to overexposure, right? So if you look at those guys like going off of the big jumps on the BMX bikes, like the huge J jumps, they didn't go straight to that. They started off when they were kids, jumping off of planks of wood in their driveway. And every time you don't get hurt by that, your brain records that. And so oftentimes anxiety arises from lack of exposure. This is new, it's different, it's outside my experience, therefore I'm nervous about it. Behavioral conditioning, operant conditioning, I don't remember what it's called. There's something about it, but behavioral modification. Anyways, so what you do is, instead of jumping straight into the wild parties, you go to a quiet park and you find somebody sitting on the bench. Exposure therapy, that's the one. Yes, thank you. And you walk up to them and you just ask them what time it is. That's it. And then you walk away. You don't have to ask their name. You don't have to say anything else. And then your brain eventually gets used to the idea that approaching somebody for a brief time is not dangerous. And your brain rewires itself to recognize threats. And so it's like, oh, this is not strange and unusual. We do this all the time, and nothing bad has ever happened to us. Then you escalate to, now I have to say 3 sentences to somebody, maybe. Or, I don't know. It's about exposing yourself in a safe environment to the thing until it no longer causes anxiety. It can take time. I've never done that. Well, that's not true. So as an introvert, I really hated social interactions when I was younger, and I got over it due to lots of exposure. It was a little bit more of a thrown in the deep end kind of thing than a gradual increase. Basically for 2 years, I was required to talk to people every day, all day, strangers and the like. So that kind of got me over it. I learned my social graces. I learned how to behave so that I didn't appear to be an introvert. I had people believing I was an extrovert. But it was still exhausting. I'm still an introvert. It didn't change who I was. It just means that I was able to operate in a broader set of contexts. So yeah, exposure therapy, good stuff. Just, take it slow. Actually, the same thing would happen physically, right? So I have an allergy to peanuts, and I could train that away. I could start with, micro-dosing peanuts every day, and slowly increasing that until my body realizes it's trained itself that this is not a threat. I haven't done that because I don't care about peanuts. Like, why would I? It hasn't. It hasn't. I don't like the smell of them. I don't like the smell of peanut butter. I just don't want to go through that. If it was like chocolate, I'd be like, you know what? I'm going through this exposure therapy. There's no way I'm not living without chocolate. So, just a matter of priorities, time, and patience. Consistency is the key. So, but anyways, glad to hear your interview went well. Yeah, cool. So hopefully you get a follow up for a technical interview. Those are more comfortable for me, I think. I like answering technical questions more than what would you do if somebody disagreed with you and they were your boss. Like, well, I'd do what my boss said after I told them they were stupid. No, I wouldn't tell them they were stupid, but I would tell them they were what I thought should happen, and then I'd do what they tell me. But anyway, that's not exactly rocket science. It's not interesting. So back to it. So this is why we're going to spend so much time generating code. We're not going to profile any of these because right now we're not emitting enough. We're not going to be processing code end to end. When we have all of these done, and we can process a file into tokens end to end, we're going to make sure these all work. And then we're going to build up a large base of code that we're going to tokenize. Probably JSON. A JSON parser is pretty trivial. And we're just going to download a ton of JSON files, and then we're going to measure it with basically every combination we can think of that makes sense. We'll turn each one on and off, on and off, on and off, and just see how much each one individually contributes to performance. That'll be an interesting thing. Diako Kurdo, are you working on the compiler? Yes. Yes, I am working on the compiler. Yeah, technical interviews are way better. Yeah, so we're talking about, we're going to be emitting code today, and we're going to emit code for each combination of performance affecting behaviors. So we have an iterator to go through a text file, but we can also just do it with a for loop ourselves and not use the iterator. We can tokenize the whole thing into a single array once. That's the batch. Or we can just generate a token when you want it. Those have different performance implications, right? We're going to get better code locality and spatial locality in memory with a batch. But with lazy, we don't have to store nearly as much. We just need one token at a time that we're storing. So we can save ourselves a lot of memory operations here. So which one's better? I don't know. We're going to run both. Same thing here. We're going to dispatch our states, our DFA states, in 3 different methods. And yeah, so this is what we're talking about. These are all things that we're going to take into account today as we start generating the DFA processing code. So with that said, step 1 is we're going to ignore the go-tos for now, and we're going to do this by, we're going to start down this road. We can generate a function for each DFA state, and that would feed directly into either the switch or the array use. Right? One is a switch onto a function, and then the other one is we'll gather those functions into a list, which we look up by index. The go-tos, the body of the function will be the same in the go-to label section. So we're going to start by emitting one function for each state. Hopefully that makes sense. In my old code base, we basically went with the bare character reference. No, I don't remember. It doesn't matter. I don't think this one is as important. We did batch processing. We did it all with go-tos, and the helper functions were all functions. So that's kind of what I'm most familiar with. So we're going to start by emitting a function for each DFA state. So hopefully that makes sense to everybody. And that's where we're going. And we'll see how far we get today. There's a lot of permutations, which we should put into our notes. So let's move this into our journal. Meeting DFAStates. We're going to pound to find out choices that might have performance impact. Okay. So let's go look at what this might look like. And again, this is the go-tos version. If I go to an old code base, pilot tour, VB parse, Billy, Tokenizer. So there's a lot of helper functions, etc., etc. That's how we accept or not. Okay. So here's what it looks like with go-tos. We're basically going to capture this body inside of a function. Same thing with this one, right? State one, it's just going to get its own function instead of a label in a go-to. That's the main difference. But it's also going to just look exactly like this, right? State 2 looks very simple. We have a long list of DFA optimizations that we might go with. Like this text, I bet, shows up in multiple states. Wow, we don't. Okay, well, that's cool. I don't have to disambiguate this, or I can't remove states like that. Anyway, so this is our goal. Instead of this go-to being here, we'll return with a state ID, which will either go into a switch statement or into the table lookup. Those are the main differences. So hopefully that's clear-ish. See, here's what we're doing. A \s gets a tab, a space, or a non-breaking space. So if you copy-paste code off the inner Googles, our parser will handle it. That always drove me crazy. Anyway. So, actually, let's just snag this. This is a copy for us to look at. So in VB project, we're writing a tokenizer, but it really needs to be 2 pieces. So let's go do that. So this is one of those pound to find moments. Okay, let's not worry about it. Tokenize. Next token. Set context. Okay, so it's probably here where we're going to emit our tokens. It's be a 1 and a 2 kind of thing. Yeah, okay. So we'll throw blank lines there. So it's going to give us 2 halves. Then we want to VB project parser.hpp. Oh, not that one. Project.h. There we are. Right. Token function methods. These are methods. I think it looks like we're doing the blank outside of that. Okay. Okay. So we're going to write some things. Our depth of code, where do we do that? BB. Nope, it's in Tokenizer. We want to be 1, 2, 3, 4. 1, 2, 3, 4. A depth of 2. So writer set depth to 2. And at the end of all this, we'll set depth to 0. Writer right line pound if def what do we call it? Dispatch switch. DFA dispatch on a switch, or dispatch on a lookup table. And at the end of all this, we're going to write pound undef. Oh no, not undef. Pound endif pound endif. Okay, so basically inside of this block, we're only going to generate these functions if we're in this mode. Hopefully that's not too weird. Writer, give me a blank line. Now, VB project has somewhere in it our DFA. Which is probably the tokenizer definition. Let's look that up. VB tokenizer definition. Pretty sure this has the DFA in it. Yeah. So let's just grab that. Equals our tokenizer definition, point to DFA. Okay. Do I remember what a DFA looks like? No. Start state states. Now, when we built this whole thing up, I don't think the start state here is necessarily the last of the states. But I do think we want to emit the start state first. You know what we could do? We could to do emit HTML tables. We could emit org mode tables. Honestly, once you get to a certain point, you can just emit anything. This is what we want. Okay. So VB project CPP. We're going to say DFA start state. So we're going to emit DFAState. Then for each DFAState state in DFAStates. We want this to be constant. We're not changing anything. Emit that state if state not equal to DFA start state. So we're gonna emit our start state no matter what. I think it's 0, or if it's always 0, that's great. In fact, it probably is. I think it's the NFA I'm thinking of. We compose a bunch of little NFAs into a big NFA, and the NFA start state is not necessarily the 0th one anymore. But this one, I think, starts with this NFA start state wherever it is and builds from there. So this is probably still 0. So we probably don't need to have this step and this check, but we're going to just, whatever. We need a helper function after that. VB project. Emit DFAState. Oh, I guess we need to handle the writer as well. The writer and a DFAState. So we need DFA and DFAState. Skipping DFAState modulus D state is already emitted as start state. Now I don't remember what's in DFAState either. It's been too long. It is a state ID. Okay, and all we're going to do for now is we're just going to emit a comment. That's all we're doing. Writer point to zero 2D. Why not? And we want to know two things. Is this a start state? So let's have modulus S, and can it accept modulus C? Actually, yeah. So if it's your state point to is start, if it is a start state, we will mark that bad boy up. Otherwise, we don't do anything. State point to can accept. If so, then plus. Ooh, I don't remember. Maybe just a minus is fine. That's fine. Okay. That's basically all we're going to do here for now. Let's see if this compiles and runs. Why is Scratch been saved? Okay, Scratch. Okay. That is bizarre. Oh, clean and test. Thank you. So now it's emitted. Oh, it didn't. Oh, because I. Oh no, it should have. Right, token methods. Oh. Needs the writer. Okay. So let's go take a look at our retest parser. Tokenizer, okay. So in here somewhere, skipping DFAState 0. Okay. I think. Watch this S. So state point to state ID. There we go. That'll help quite a lot. You have to have the right number of parameters when you're formatting a string. Okay. Test parser, reload. Okay. DFAState 0 cannot accept, but is the start state. DFAState 1 is an accepting state, 3 is an accepting state, 4, 5, and 6 are. 2 is not. I would like the one extra space after that. So we're going to do a writer blank. Okay. Anything else we want to do before we start cranking away at this? And this is unnecessary. Just simplify it. Dispatch switch and lookup. Yes. Okay. Let's see, void DFA root state modulus 0, 3D, I guess. Why not? This will be state ID. Did I put a comment in the start state? I hope I did. Yeah. So we can do that. All of our state will be internally managed here. This is a push operation, isn't it? Push. Writer. Pop. Probably need a const ChrRef. Oh, that is a good question. If we're doing lazy, we don't pass in a character reference necessarily. Yeah, it's fine. And C. Okay, so that should all be a thing. So let's run that and see how it looks. Well, test parser reload. There we go. Now each one has its own function. And they're all the same, which will be important later when we do switch by function pointer array or dispatch. Somewhere I need to document all the performance switches. Let's just add them to doc. Performance switches .org. Something is text buffer. There's 3. We're going to lose track here pretty quick. File reading. Iteration. Text for each. Text for maybe something like that, which we can go ahead and put in our TxtBuff. Oops. If def all the way down to the end of the iterator there, and if. There we go. So that's in now. Tokenizer. Token processing. Get around to that. State dispatch. Helper functions. If we don't have these all listed out somewhere where I can find them easily later, like if I just write these in the journal as we go, when it comes time to actually run the performance tests, I won't be able to remember every combination, and coming through all the files to find them is going to be a disastrous nightmare. So there we go. For now, we will define this one. Let's see here. Defines plus equals dash d text for each. It's going to be its own whole block. Okay. We're going to go for switch, I guess, first. State dispatch switch. F pointer array. Let's just do this as a prefix, then we keep it. Let's not be silly. DFAState dispatch, I think that's good. Token processing. Process lazy. Process batch. Helper functions, sure. Helper macros. Okay. So this one is done. I'm just gonna, let's see here. Can I done? Iteration is done. It's done. DFAState dispatch is definitely not done. That's definitely not done. But we can do the helper functions. Let's go do that real quick. Tokenizer CPP. So if we're doing helper functions as functions, this is what it would look like. And if, or else if f, wow. You can tell the old autopilot is strong today. Pound end if. Now if not, I need to pound define these somewhere. If def helper macros. and if helper macros. Oof, okay. And helper macros actually needs 2 chunks. Pound define start new token. That's basically it. Except for this one. Just line it all up. So macros just do text replacement, basically. So when we call these macros, it just replaces the text where we put this with all of this. Same thing here, same thing here. But we do have to also undefine those 3 things down here. If we're using helper macros, undefine much. Oof. You know what? I want them to look different. Start new token. It's usually my policy that macros are all caps. Okay. Undefine much. Undefine start new token. And undefine new line. Okay. So that should be that one done in our what do we call that? Performance switches. So I would say this one is done. Those 2 are in to-do list. To do is kind of done. It's done as far as TxtBuffer itself is concerned, but it's not done as far as anybody using TxtBuffer is concerned. So we'll wait until we get a little further along. So these are just performance switches we want to turn on and off when we go to finally profile and measure our code. Okay, so back to Tokenizer. I would like to just see if it's, of course not, VB project. So let's run a compile, clean and test. Fat finger to that. Try it again. I'd like to know it's working and compiles. Since we just did a bunch of pound define stuff. Aha, so you see, we already have differences. So if we go back to our tokenizer, luckily this is an easy fix. If def helper functions supporting macros, we do things one way. If we do functions, it's the other way. So yeah, we're going to go way overboard on how much code we're emitting because we have all these different permutations. So we did not get an error this time. Okay. Perfect. So, our DFA table. We are working our way through it. So we've got a function for each thing. Which means we can get rid of this mostly. I do want to add a function here, writer top. I think we care. Yeah, that just all goes away probably. Okay, then what happens is we need to walk through our transitions. That's in the vector 4. DFAState transition in DFAState transitions. And each transition is going to have inclusion rules. Then we're going to decide what to do depending on the number of things. I have to go now. I'm meeting a friend. Have a very nice weekend. Yep. You have a wonderful weekend, Javest. We'll see you on Monday. Have a good one. Bye-bye. Transition. Do I remember what a transition looks like? Inclusion set, an operation. What's the next step? And rule ID, token ID. Okay. We're going to pause here for a quick restroom break. And then we'll, yeah, get started in this. Okay, and we are back. Let's see here. Okay. This is the part where we actually fight our formatting the most. If you remember this Tokenizer, we have sometimes one entry, we have sometimes multiple entries. We have ranges of entries. So there's capital A through capital Z and an underscore. I believe we have not as well somewhere. It's been a while. Not. Here's the not. So it all gets a little bit hard to line up your code well. Now, I don't see any that I don't think I could fit on one line and have it be okay. Is that true? Is that a true statement? Oh, man. Ugh. So maybe we can simplify our lives a bit. Okay. Try to think through which sorts of things I want to do here. Maybe do the project. All right. So for each transition, we get the inclusion set, the op, bool first transition. First transition. False. File writer. Let's take a look. I think I'm going to move that up here. We're going to prefix white space. If otherwise, I'm going to write else if. Okay, then for each inclusion rule and inclusion set, we take them together with or. Ooh. I'd like to ask the question, is this the last transition for the DFA state we're in? Which means int last inclusion index equals state. No, not there. Transition inclusions inclusion rules.len. Rules.size -1. X equals 0. Plus index. Okay. Now we can ask the questions we need to ask. I think. So prefix everything. Last transition index. Might be something else I want to keep track of. because we will finish things off differently. Last occlusion index. Occlusion rule. In transition occlusion. Index 0 plus occlusion index. Okay. So you have to do a lot of bookkeeping just for formatting purposes. So we have an if, we have an open parentheses. For each occlusion rule, we're going to write out the rule. Except here. If DFAState. So if the transition op equals DFAState operation, exclusion we need an extra paren and a not. After we've gone through all of this, we have to close that extra parentheses. Okay. And for each occlusion rule, you need to open a parentheses. And close parentheses. If we have more than one rule. Okay. Okay. See, this is already going to become very messy. Guess we don't need this anymore. Transition index equals 0. That simplifies. We can even simplify a little bit if it's not equal to 0. Not on the first transition, it's an else if. So if this is not occlusion index not equal to 0. So this is not our first occlusion. and we want to put in verticals. Then the rest of the inclusion stuff. First one, paren to paren. Oh, I see what I did. Okay. Or parentheses. I just need to set the conclusion writer point to right C equals a thing, or oops, XYZ less than C and C less than equal to something else. If this is a range, is range. If rule is a range, otherwise we just write a single check. Ooh, okay. Let's just see if this follows a shape that reasonably simulates what we want to do. Do that. Okay, so we've got if, paren, bunch of stuff, paren. That's only if you have the not. So then we do writer, right, close the actual parentheses, thing, writer blank. We're just stubbing this part in right now. No, I think we push this, write a blank, and then pop. Unsure. Let's just see what it looks like. It's nowhere near correct, but that's fine. If parts of it look correct, we're going to take that as a win. Or inclusion set. Okay. That is indeed a colon instead of a semicolon. We probably did mean to use a pointer here. Oof, okay. Cranking along. This is not gonna, let's see, so DB test parser. Reload. Okay. Shockingly, this is not as bad as I feared. We clearly have some trailing space issues here. And we emit a bracket when we don't need to, except after the last else if. This is why we have to do the else if thing. But that actually formatted out quite nicely, I think. Oops. Cool. Now you know why we were keeping all of that bookkeeping we were keeping around. So we can emit code like this. Oops. Okay, ABE project. That's actually kind of coming together nicely. Where did all those spaces come from? If last transition index equals transition index. Then we do that. I usually do my logic the other way around. Okay. Somewhere where we do the prefix white space. Okay. If transition index not equal to Are we calling this somewhere else? No. Where did all those extra spaces come at the end? Ooh. Okay, so this does a push. That is the problem. And now there's no thing which does a pop. And that push does a prefix. So push is not the correct answer. Savage Lord Severus, evening, afternoon, etc. Yes, hello, hello, welcome. How are you doing? Doing okay, been playing with bot again, added some cool stuff and some mean stuff. Oh, we don't want mean stuff here, but I'll take cool stuff. Cool stuff in bots is always nice. Okay. We are close to what we want. Okay, for me to bring in the show you? Yes, yes. Yeah, you didn't abuse any privileges last time, so feel free. And we'll take it for a test drive. Okay, so after each else, I think there's always an else at the end. No matter what. Go look at our example. I think for every DFAState, I think every single one ends in an else. It's either an error or we accept. Error or accept. Error or accept. I think there's always an else. Okay, so if we go here, after this last one, we're going to the last transition. Prefix white space, right, else. This can be this can be a push actually. And pop, end of that statement, point to blank, blank in, so let's see. We probably should do that. All right, let's take a look. Let's see yours. Main stuff is insult. Okay. Insults can be funny. I mean, if you're here, who's covering your role as the village idiot? Yep, classic stuff. Old school. Of course, it can't get very personal, right? Who doesn't know your gender, race, ethnicity? I'm going to call you Rain Cloud because when you screw off, it's a beautiful day. Or I can add someone. Ooh, there you go. Okay, all right. Okay, so that's insult. All right. Bad bot. Which type bad bot? I don't put the exclamation mark. Finding it difficult to underestimate you. Very nice, very nice. All right, what else you got? What other features you got? Okay, this looks like it's almost compilable already. Look at that. I mean, it's not, but it's close. This is actually not bad formatting. This is the next piece. Where perhaps this is the most difficult one. Once this formatting is done, the rest of it's formatting-wise very straightforward. All right, what other new features have you got? Need a change of gum here. Okay, we're rolling D20s now, huh? Oh, you can use the actual normal rolling format. Roll. I crit failed. Nice. 3d6. Got 154 for a total of 10. Hey, it's correct. It even added them up for me. Cool. All right. Are you a D&D player? Or are there other better systems you prefer? So the one thing I liked about the older styles, let's see, go to really Tokenizer. Oh, that's fine. So I could explain what this number meant on the line where it occurs, which I cannot do. In fact, I suspect this is this. But when we expand this all out, this is exactly the same thing. So if we have a whole bunch of equals checks, append explanations, is there like a thing we can do? Maybe that's what we have to do. So after each one of these, you can use moon for moon phase. Oh yeah, moon phase is always a good one. Current phase, very nice, very nice. Weather US followed by a city name. Weather. So let's see here, a good city. That will show the correct emoji too. I see that. It's I didn't realize we had emojis for the phases of the moon. I'm a little bit boomer when it comes to emojis and all the latest shortcuts, leet speak nonsense. What's a good city? Let's go with Denver. 69, 4-mile-an-hour wind. Very cool, very cool. I've played D&D and some other D20 stuff, never really had the right group of friends to play any TTRPG for extended amounts of time. Yeah, that's kind of where I'm at right now. Well, sort of. It's a long drive to hang out with people. Did have a really fun paranoia session one time. That was interesting and funny. Yeah. One system that I quite liked was Fiasco. That's good for one session. For one shots. Basically, your odds of winning are almost zero, and it's more about how absurd things get as the world falls apart around you, and it's hilarious. It's like a take on those old like failure thief heist movies where they fail at the end because everything just goes against them. It's like that, like like Fargo, right? The bad guys are just, their whole life just falls apart because I think the phrase was their ambition far exceeds their capability is the kind of person you're playing. And it sets things up in an interesting way. A lot of the Fiasco scenarios have an awful lot of inappropriate material in them. But if you find a couple of good ones, like it's good for kids too. Like I ran one with my kids where you're like out in the swamp and like half of them are Bigfoot hunters and the other half are drug dealers. It was hilarious. One of them was like a camera crew from a big news network trying to follow the Bigfoot hunters. Or there was another one we did. It's basically an underground fighting ring, right? Like Bloodsport or Karate Kid or any of those sorts of old kung fu movies. And yeah, those always end up with people getting injured and broken. And we did have one guy, he fell in love with one of the contestants and ended up getting the crap beat out of him, but she did fall for him in the end. So I guess, once in a while somebody ends up with a glimmer of happiness, but most people end up broken, and it's just the journey to get there is hilarious. So I recommend Fiasco. That's a good one. Yeah, Paranoia. That's the one with the Jenga tower, right? Yeah. Well, cool. Okay, so we need to replace these XYZs with something useful. Then we need to think about putting something off the end to represent non-ASCII characters. Okay. So anywhere we see X, Y, Z, we output a string. So let's write ourselves a little helper function here. New project. Void. Let's take a look at inclusion rule real quick. To string is very similar. Anyway. Start C and C. So these are UTF-8 character references. Char to string. UTF-8 character reference. Cool. Char needs explanation and char explanation. I want to have a file writer for these two. I don't want to return anything. I just wanted to write it out. So let's start stubbing these out. All in the name of good output. Accept. Or, I'll just put on thing. Error. Okay. Boom, boom, boom. Project. Okay. The most important one is this one. So we would change the name of it. To write char. Write explanation. Okay. So write char probably isn't that bad. What do we have here? Value. This is the key right here. Unit32v equals our value. Now, if v is between the visible characters, and we'll do specific things. I can't remember the ASCII table, which way it goes. I think it's first printable character is I guess space technically. We can go from space to tilde, I think. We want to output the character of v. That's basically that. If v equals new line, we can do that. If it's a tab, we have to put a tab. I don't know that we care to do any other style changes else. Right. 0x modulus x of that value. Okay. You know what? We can simplify this. Bool All right. I'm trying to think if there's anything I'm missing. New line tab, all the printable characters, everything else gets a hex value. But, okay. We need to return true. Return result. This else is the special case. This is the one that needs an explanation. So we're going to result equals true. This needs explanation. So where x, y, z occurs, writer, right, nope, right character, right char, is our rule to start character. And we'll output all of that junk. Then we'll write the end character, I think. Start C, end C, yeah. This one just does that. Okay, and conclusion rule. So int explanations needed equals 0. Explanations needed plus equals right character question mark 1, otherwise 0. Okay, after we close this off, right. Yeah, explanations needed. Greater than 0. Writer, right. I'll just be entries need explanation. Sure. All right, let's see how bad that is. Honestly, this is coming together a lot better than the last time I wrote this junk. Because I knew which tacts to avoid. Huh. Writer, right thing. Okay. Yeah, I guess we could just do a right line there. Ugh. Right with replacements. Okay, so need this. Basically, I call it F right, actually. I think that's what we need. We need a right. We need a formatted right. Exposed and available. Writer. Assert that we can write things. Okay, whatever. Back into QB project. This would be formatted right. Okay, try that. See if that gets us through. I'm still around, by the way, just lurking and playing with NeoVim. Lol. Might just Vim. No. No, I do Emacs. Emacs is way better. Might just use the Vim plugin for VS Code, to be honest. Yeah. There was a time when I had my Qt. I never got into Vim. I figure as long as you're into one or the other, you need to know one or the other. That's my opinion. But I started with Emacs, so that's what I stuck with. I only knew one person ever in my whole career who could use both equally well, and he only learned the second out of spite. Funny guy. Actually, one of the few people I worked with that I ever thought was actually enough smarter than me that it mattered. But he was a Vim guy. I was an Emacs guy. We went back and forth. It was funny. But he switched jobs. He was working at this place, and one of the guys there was like a Linux nut, absolutely goo for Linux, like the unhealthy religious kind, right? And he was all about Vim. Went on and on about Vim and on and on. It finally got so under my friend's nerves, like under his skin, that he refused to use Vim anymore and switched to Emacs. So that every time he'd type things in front of the other guy, and every time the other guy would come over to look at something on his machine, it was all Emacs. So there's just so much work involved in learning the other system. Once you've learned one, like the learning curve is steep, but once you hit the benefits, like it's worth it. But like switching over, you lose so much productivity while you're ramping up on the second one. Wanted to get back into it. Got Tmux and nvim set up in a console, but I still like some VS Code stuff, so the extension is nice. Yeah, even people that absolutely hate VS Code will often bring it up just for the debugger, if nothing else. So unfortunately, debugger's probably the... Oh yeah, text. My bad. So if you're on Windows, it's still a thing. Oh yeah, that's probably an F-right as well, huh? I feel like I'm getting to the point where I need to refactor my file writer a little bit to give cleaner functions over some of this stuff, but okay. Okay, test. I kind of don't care if that. I don't really care if that compiles right now. Maybe test parser. Oh, it didn't output at all. Yeah, so well, that's awkward. Well, that's just terrible. GR run. It is site faulty. Yeah, still got some weird issues, mainly due to being in WSL2, to be honest. Yeah. LSP is not seeing all the modules I'm installing, etc. You know, I have still never set up or used an LSP. Oh, for those who are new, it's a language server protocol. Basically, you can hook up your editor to just about any LSP, and it's basically a background process running on your computer that constantly analyzes your project. And then your editor can read the symbols off that and update the user interface based on whatever LSP you've installed. So, or extension LSP thing you've installed or plugged in or whatever it's called. Which means that your editor is now decoupled entirely from whatever is processing the language for your viewing pleasure. Yeah, so just for those that don't know what one is, I guess my thing is the more I use one area of code, the more familiar I get with it, and then the LSP really slows you down. Like maybe when you're first starting into a project or into a new language or something, an LSP can help. But I think after a while, it's a lot of times it gets more in my way, and this is with auto completions, all sorts of things. Like it's just I have to click off to get it out of the way. It just annoys me. So, and also I think while it can feel like you're more productive in the beginning, I think in the long run, you start being lazy about what you remembered about your own code. So it can actually mean that over time you never really learn your code base forward and backwards and inside out. It causes different kinds of issues. So I'm not sure yet LSPs are a good idea, but it's like learning to draw. You could use an AI to do most of the drawing for you, but then you're not learning the fundamentals, right? You can skip over the very beginner crap, but it's not, you don't learn the fundamentals that you need because something's holding your hand the whole way. There's probably a correct balance somewhere. But the more you have to context switch while you're coding, I think it's the worse it is. So backtrace, previous frame is corrupt. Okay, so we're doing something corrupting. That's unfortunate. And it won't tell me where. So consider what we just added. It probably has to do with fwrite. We certainly can, right? We get args. printf to the file, the text and the arguments. Then we end. Huh. That is a little strange to me. A little strange. Yeah, I'm tempted to just disable it for the sake of not having a bunch of errors. I know we're fine. Yeah. It's all down to personal preference, I guess, but I don't know. I just can't see myself using LSP. I think I just get mad at it all the time. I have no patience with a machine telling me the wrong thing over and over again. Like autocorrect. Like, oh, did you mean this word? I'm like, no. If I have to click to tell you that I am right, I don't want you to be intrusive. It's like I don't mind a little bit of autocomplete here and there, but I like. So, for example, if I want to type something into your UTF-8, I ask for it. Until I say Alt /, it does not do an autocomplete for me. It is not an automatic thing. It's an I asked for it. But yeah, anything that tries to pop up and correct me and help me and autocorrect me, I won't put up with that crap. I hate it. Okay. None of that did anything. Didn't change anything. So where are we getting this? Where are we getting this strangeness from? Okay, let's do something different. Ready? We're just gonna write XYZ, which is definitely wrong and invalid. Oh, let's just do that. Why not? And this one as well. I think I heard the Primogen say something similar. He tried using Copilot and LSPs, and he eventually ended up turning them all off. He goes into a pretty good explanation why. Okay, last occlusion index. I don't think I'm actually using. Occlusion index, I think I'm only checking for the first one. Which, if that's the case, we can just say bool is first occlusion. True. It's first occlusion. There we go. Use parameter, that's fine. We're not doing anything with this one. And then I'd use parameter as well. Nothing else. So here on the old shell, oh, how did that work? No. There we go. Now we run. There's no backtrace. Ah, okay. Let's see. I've never touched Copilot, never will, lol. Yeah, exactly. For one, I don't want to try and train an LLM to do my job. Yes. Which is why I don't post any significant code to GitHub either. Only small snippets of useless stuff. For two, because they comb over all of GitHub to train their LLMs. I'm not going to hand them the tools to to train something better than me. Not that it is, and I have a lecture on why that's not going to happen, but haven't given it yet. So for two, they write ridiculously unsafe and insecure code. Yeah, well, and so one of the things that the Primogen pointed out was you tell it, hey, I need a little piece of code that does this, and it does that, right? But then what happens is it doesn't see the whole picture. So what you'd end up doing is you'd have this little piece over here and this little piece over here that does that. And then when he started gluing them together into a whole, the system just had so many subtle little bugs of, this thing doesn't quite match up with that, and this thing doesn't quite interact with that, until, it's just unusable. And debugging it was very hard because it was subtle problems that he hadn't built himself, right? When you know the whole system, because you built it, it's very different than if you let someone else build little pieces and then you find out later exactly in what ways those pieces don't interact the way you think, or the way that you would have done it. Am I a college teacher? No, not a teacher, or professor. I'm none of those things. But I do have like little mini lectures that I've written up that I plan to give sometime between games. I'm gonna write up a game, do like a beginner programming series, and maybe do a couple of lectures. Like do a, here's how Emacs works, here's how I use it while I set it all up. Maybe like one about why LLMs will never replace me as a developer. Things like that. I've kind of got notes written up, ready to do a final write up and a presentation on. Just trying to be prepared, have lots of ideas of things to talk about on stream. So, yeah, I'm not a teacher. They probably wouldn't want me as a teacher. So we're segfaulting, huh? Okay. Pretty sure that one is safe. Do you think you could bring yourself down to be giving beginner tutorials? Absolutely. I have perhaps some strange ideas about computer science that I would love to present in a more, not formal, but a more structured thing than I usually get around to. And like I said, I've already got the lecture partly written. I just flesh it out, put some images on it, or make it a presentation, make it a little more official, a little more formal than just spouting my theories. But yeah, absolutely, I think that a lot of beginners get off on the wrong foot if they want to be serious. It depends on what you want. Like, as a hobbyist coder, I can see that a lot of things that I've thought of don't matter to them at all. For you want to be good at coding, I think we start off wrong. And that's me self-included, right? I consider a good portion of my college education to be a complete waste of my time. Yeah, no, we'll do some beginner topics between games. I want to wrap up a game. I don't want to get too sidetracked with too many side projects. But in between, we're going to do some beginner series. We'll do some, mini projects, more the kinds of things that you see on like YouTube. Just little tiny things. Do some personal learning of my own. We'll philosophize, all that good stuff. I second that motion to have some beginning topics to unlearn my bad habits. Yeah. I don't know how many bad habits you have, though, JTL. I'd have to... Anyway, more just to restructure the way you think about programming a little bit. This is kind of where my lectures need to go, I think. I want my nieces to learn coding, but don't have the time to teach them personally. None of the online courses feel good enough to teach them to my level. Yeah. Yeah, online courses I would be very dubious of. And I know that saying that I plan on throwing a couple of lectures out there on the topic. Which, may be hypocritical of me. But I think that I have not current ideas. And it might be helpful as a starting point. Which kind of raises the question, I guess, of if college isn't a great place to learn programming and online courses aren't a good place to learn programming, like, it still kind of means if you want to be a good programmer, you kind of have to teach yourself, which makes me a little sad, because that is harder. But on the other hand, it's also very exclusionary, right? Only people that care enough to do the study outside will get there. And honestly, most coders don't need it. Most coders don't need to be high skill. Most of them are slapping together a couple of statistics packages, and it's good enough. Here's a matplotlib, and you're done, right? You don't have to think much about the coding. They're more concerned with the process that they themselves are engaged in. So, yep. Yeah, so I have some beginner ideas of things that I think would help beginners. I would be curious to see how that theory pans out in reality. Web devs. Hey, I didn't say it specifically. but yeah, web devs are pretty notorious for just gluing crap together until it works, technically. Not all of them, again, not all of them, but a significant enough proportion of them that it's a problem. My web sucks. I load up a page. I have, 600 megabit connection. I have a screaming beast of a machine, and it still takes me 6 seconds to load a page or 10 seconds to load a page. It's just disgusting. I'll be honest, the front end devs I've worked with have been a godsend. Sometimes, yeah. One of them was really smart. Okay, all right, yeah. So you met one of the good ones. Good. Yep. Most of them are grunts who do that. Yep, exactly. Do the FE work while I do the heavy lifting on the back end. Yep, that's often how it goes. Often. Okay, so if we're having a seg fault, we need to cheat. We need to figure out what we're doing wrong. Somewhere in here. Okay. We're just going to take everything out and see if it works. Oh, but that means it's still segfaulted. Well, that is odd. Very odd. Yep, still segfaulting. That's puzzling. This build is succeeding. Then it runs VV over our project file. Is this segfault then? I was in a company over COVID, nothing super advanced. They were just an affiliate company, basically traffic shaping for gambling websites. Okay. I wrote a sweet little snowflake of a lambda to generate a tracking code containing a bunch of user info, source, website, target, click statistics. Yep, then the FE dev made a little tooltip to show the users how to embed this tag into their affiliate links with something like tracking tag. Sure. Did he get all of the accolades and kudos for putting in a tooltip? I gave the demo, they specifically called out how cool the tooltip was. Called it. I've been in this industry too long. I know the pattern. Yeah. This now has me very puzzled. Is it because of something I did with file writer? You know, like, never mind the absolute magic that does the work. He did a string replace. Yeah. I was in my first job out of college, and there was this absolute disaster of a program. Not that the program itself was a disaster, but the way it was run was a disaster. A lot of devs spent an awful lot of weekends and hours, way over working hours, to get it all done, right? And then the company, not the company, the division, had like a special little celebration thing after we delivered the product, right? And they called out all the people who weren't developers. They're like, oh, thanks so-and-so for working the contracts with the customer, and thanks so-and-so for going over the requirements documents with the customer, and not one single developer was thanked, not even mentioned, not once. And yeah, we bled over that. I wrote a specific tool just to improve the workflow a bit, and not one developer was mentioned. The IT crowd. Is that the British one? With the Irish guy that... Have you tried turning it on and off again? That guy's hilarious. And Moss, and what's his name? Yeah, that one. Yeah, there were some really on-the-nose ones. I love the one when they send their manager to the VP meeting with the internet. Roy, that was it. Roy and Moss, yes. They sent her to there with the little blocks with the blinky LEDs that they called it the internet. That one cracked me up. This is the internet. Oh, yeah. Yep, that's too funny. Too funny. Oh, did that finish? It did finish, so it's something I'm doing wrong about this. That's awkward. Huh. Huh. So we can write. Here's our list of arguments. We start the arguments after the text parameter. vprintf. The same exact thing we're using here. Like we literally just copied this. I just don't want the new line at the end. I need an unformatted version of write. So much of that show is so relatable. The bosses, the two bosses, the one that kills himself, and then the other one with like the Star Trek episode that he films. Oh, they were so good. So it anyway, I spent some time in IT support, yeah, before forsaking human interaction and moving into SecOps. Before I moved into dev properly, yeah, that's a pretty common thing. I think a lot of people go IT first. Seems like it's easier to find a job in IT, probably due to high turnover rates. But YouTubes. Oh, okay. Yes, Aunt Irma visits. Yeah, that looks like the right one. No, I don't have any like long, deep and traumas or anything. Just I'm not mad. I'm just disappointed. How's that? That get me there? Ugh. Oh, I have open and close bracket. Really? I don't do that. Okay, well, whatever. Either way. What if I call it format? Would that fix it magically? That's unutterably stupid. If that's the case. We assert that we can write. We get our args. We start arguments after the format. Print virtual file print and end args. Not virtual, just varg. Nobody's using this function. Nobody's using this function. But if I put it in, it breaks things. Nobody's even calling it. Even though I literally copied this. What if we put that in? I don't think that can help. What if we change the name? What if it's because it's calling, treating it as a... I didn't think F right would cause me a problem. Right F. Oh, and I remember H files from iOS dev. Yeah. So that seems to have been the problem. Okay. I mean, I know that F right is a predefined function, but I didn't think it was a keyword that would override a file of method name in a different scope entirely. Either I don't understand where F right happens, which is possible, I suppose. So this is now just... okay. Nope, I did not like that either. Okay, right F. So lame. Reserved word. F right is a reserved word. I thought it was in stdio. F right. So like you'd have to import stdio to get that symbol. If they have that as a reserved word, that makes me mad. F right, defined in stdio. Ugh. It being a thing is one thing. Why wouldn't parser just tell you that? That's also true. If there was an ambiguity, or yeah, the compiler should tell me more. Up until now, Python didn't tell you if you named a file in the same as name as yeah. Okay, all right. That should not be a defined word. It's an included library that you can define by including stdio. That's my opinion. And my opinion is right. Okay, anyways, after that lovely little sidetrack. Oh, XYZ. We're still doing XYZ things. Yeah, right here. Oops. Okay, nowhere else. Everybody's behind the times. Yeah. We have modern computers. We could analyze the code better in our compiler. I think it can be done better. Okay, we're getting a new line in a couple of places where we don't want it. Basically anywhere we're using a regular character. So this one, right F. Oh, probably because copy that line. Okay. Yeah, but as he says, he wasn't even importing it. Yeah. Well, I'm defining it as a member of a class. Like this is within a different scope. Anyway, oh well. Python file random type because you're making something that involves using the random module. Even if you don't import random into your script, it still won't let you use it. Yeah, okay, so here's an example of that. Let's go back to our occlusion set. I have a function called onion. Why? Because you can't use the word union, but at least that is a language-defined keyword, right? The union operation of two sets makes sense. And it's a union is within C and C++ a defined keyword. I don't think F right should be in the list of keywords. It's just a built-in function. Half broke, back broke. So typing is garbage. Yeah. Yeah, no worries. I can often interpret what you're trying to say without having to correct yourself too much. So this one at least makes sense. Like union is an actual language keyword. Fwrite should just be a built-in function, not a keyword. Where was I? So we're looking at VB test project again. Parser. Boom. Okay, let's take a look here. New line or return carriage return underscore or between A and Z underscore or between A and Z. New lines. Forward slash. Oh, I should take care of backslash. Actually, that's a thing. A negative number of entries need an explanation, which is this one. That is an odd number of entries that need an explanation, which probably means we need to actually tell it explanations needed. It should be 1 in both of those cases. You know, it's funny, I specifically had to fix built-in functions not overriding other functions or variables I made in the A.io interpreter. I had the same issue with my built-ins, but I fixed it. Oh. Okay, all right. Hey, everything is looking groovy. That is not correct. Still, it did not build. Changed things. I can swear I did it. Oh, aha. No matching function for call to write. It needs to be write at. That's why we didn't get any further. Yeah, built-ins are great until they're not. Until you run into them. One entries need explanation. Perfect. Oh, finally. Therefore, we should write the explanation. In this case, it's a non-breaking space. If we, let's first verify source. Let's go to this thing. The tokenizer definition. Let me grab some letters. Just so that we're, let's see, resources, ASCII tables. Perfect. Let's go grab some 2-byte characters. Okay, so one thing to consider is even if it's in this range, you have to ask if b equals a backslash character. Otherwise, we do this thing. So you have to do that because it is a printable character, but we do have to escape it. Which does make me a little sad. Over here. Maybe test parser equals this. We're doing one thing. I'm doing something else. Okay. Actually, VV or UTF-8 character reference to C string writer write temp delete temp. We may expand this library eventually. Ampersand NVSP. Like there will be other special characters, I suppose. That's not the point. We're going to get some non-English characters into our language real quick. So let's go with test.v tokenizer definition. I'm going to say we can go from to lowercase ya. Boom. We did duplicate some lines. I don't know why we did that. Actually, let's just do this. Maybe we can get some Greek letters too. Where does Greek happen? Greek happens up here. Which also oddly starts with an A like character. Through, where does the Greek alphabet end? There's a omega, lowercase omega. I don't know why this is the Cyrillic alphabet goes capitals, then lowercase, capitals, then lowercase, but they're all contiguous, so it's fine. These are Greek, yeah, Cyrillic and Greek. Okay. Test.vv project. Yes, we're on UTF-8 mode. Good. So we compile that. Oops. We should see some of those characters showing up for us. Searching failed. No, why would it do that? Lowercase ya. Greek. Where's my Greek? Through A through lowercase alpha through lowercase omega. Well, let's take the Greek out and see if that fixes it. Huh. Test.v tokenizer. Insertion failed. Inclusion will make range. assert UTF-8 character is less than or equal to start character, is greater than or equal to. If we are less than 0x modulus x less than 0x modulus x, start character insertion fails, error. Oh, those are some very negative numbers. Why are they so negative? AA90. How big are they? Those are the lowercase yeah. Why are those negative? That's bizarre. Oh. I'll get the value. Oh, I guess we need parentheses too. There's some very negative numbers. Star temp1 equals UTF-8 character dot to C string temp2 start character temp1 temp2 delete temp1 temp2. Byte size equals 1. Failed. Into C string. That is not if the value is overridden, okay, I see what's going on here, I think. So it's underscore byte size plus 1. That's 2. That's fine. Yeah, that just comes out over here, huh? Okay, and then I take this integer. Copy to this string, except it's never quite that simple. Actually, it might be. So index equals 0, index left underscore byte size. That's index. Result sub index equals our value shifted by index times 8 and peel off that lower byte. Which actually might be better anyways than copying straight out of the buffer. Just doing a quick bit of reading on this. Apparently there was a bug in C that made it into C++ where comparing a signed number with an unsigned produced an unsigned result. Nice. Choose them as unsigned. This would make negative numbers positive numbers. Yeah. Yeah, no, some of C's casting I'm not a big fan of. Two bytes. Yeah, some of C's casting or auto casting is not very good. Yeah. Okay. Let's do this. Let's copy out the original strings, not the overridden strings. At least I'll know kind of what I'm getting. Why would it think that yaw is less than a? These don't even need to be overwritten values, I don't think. Inclusion rule. Make range. New character coming in has to be bigger. It's the start character. Neither of these values needs to be overridden. So let's see here. In our pattern to an FA converter, that's it for a backslash over here. Oh. Inside of an escape sequence, inside of an escape and inclusion group. This is range. If we were in a range, so where is UTF-8? Advance. Huh. Comparing them as unsigned. Yes, but I told them to be unsigned. And that's fine, but those values are wrong. Like, the text buffer contains these characters, and this character is definitely greater than this character, but what we're comparing here is not those two values. Like yaw is D18F. And even if you, oops. It's not vetoed. And the A for the Russian alphabet is D090. And that looks nothing like these two numbers. Even if you invert and add 1 to these, they don't look like this. Even if you take a 2's complement of these. Which we can do. I mean, we can force it in there if we want to. Just to see what these numbers would be if they were 1's complements. So let's do that. Inclusion rules, CDP, okay. Do you add 1 and then invert, or do you invert and then add 1? Choose complement, because that makes a difference. Step 1. You flip first, then add 1. Okay. So we invert +1. Invert +1. '71 and 70, which are printable characters. '71 is G, and 70 is F. Capital G, capital F. So it's not just a signedness issue. I've got something else issue. '71 and 70. Oh, well, that's not quite right, is it? It's hexadecimal, so we go to programmer, hex 70 decimal 112. So it's 112 and 113, which is lowercase p and lowercase q. Yeah, that's what I'm saying. Why? Well, and also the fact that we were getting. Why is it trying to do this overridden? Who overrode those values? Oh, there's like a with override option somewhere, but I don't think I. When we add a character, we can add an override like this. But that's if we're in an escaped mode. Only escaped mode ones are first for, let's see, TD 0 through 9. Yeah. S dot. Otherwise, whatever, backslash puts us into an escape mode. The last thing is we just push the new state. That's bizarre. So something's wrong with my UTF-8 processing somewhere. Oh. My current parser is not that smart. Yeah, that is bizarre. We'll have to throw a note in our to-do list. Bug. UTF-8 not working well in Tokenizer UV project outputs for DFAState transitions. See, that worked. Anyway, we need to come back and visit that. Okay. DFAState things, otherwise, yes, underscore. T. Entry needs explanation. No, it's just kind of where we needed to be anyway. So let us generate an explanation. I don't want to wander too far afield from what we're working on. So BB project. Oh, it only happens in the one place. Cool. Okay, so then. Int explanation count. Zero. If explanation count greater than or equal to explanations needed, break. We're gonna have to continue because this is all going inside of a loop. We do need that function back. Shoot. DB project.hpp. Well, does char need explanation? basically looks like this one with none of the writing. Basically that. Which is a very silly piece of code in some ways, but probably not as good as it's going to get. Anything else we build is going to be comparably hard to read. Okay. Let's back up here. First thing we want is to go through each exclusion rule. What we're looking for is rule is a range. Otherwise, there we go. If char does char need explanation of rule, not start character. Make this a little bit more efficient. If the start character needs an explanation, our explanation count increments. The rule is a range. We'll check the end character. Before we increment, we write explanation rule dot start C. And NC, okay. And if explanation count is not equal to 0, comma space. Let's see how that works. Oh, look, there's our MBSP. And this one. Nice. It's wrong, but it's there. And unless I get that Russian thing working, it's not going to be as easy to test the other case. That's fine. So why won't those Russian letters work? I want it to work. It should work. So let's go to here. For each character. If UTF each character dot byte size, I forget what we called it. Byte size greater than 1. We tested with different things, so I'm not sure what is going on here. UTF-HR of something, much of this S. Char star temp equals UTF-HR dot to C string. Delete temp. Which in our case there should be two things that say that. The Russian A and the Russian yeah. Oh, well it won't because we need to update our token. Put them both back in. Why not? It's going to crash on the earlier one anyways. Lulu. 377 to 20. So let's go into my calculator here, and if I have octal 377 as hex is FF. That's no good. Where's octal 220? It's 90. Is overridden. In pattern DFA. If UTF-8 character is overridden, totally overridden. Dude. You know those sardines in hot sauce? I put them on pizza for the first time in my life tonight. What was I thinking? Never again will I ruin my homemade pizzas. Yeah, I like fish, and I like pizza, but I don't like them together in the same place. Fish deserves to be, grilled or sautéed in like butter and herbs, or lemon juice on there, but not on a pizza. I can't see that working out well for anybody. So if these characters were overwritten, why would they be overwritten? Number of places where we overwrite a character doesn't make any sense, especially since this is. Like if you can get tins of fish, like the sardines or the oysters or clams or anything along those lines, different snacks, it's got to be on like crackers, like chicken and a biscuit or something. With cheese, preferably. Okay, we're gonna do this stuff. 0x modulus x temp and UTF-8 characters dot value. We're gonna print them both. We're gonna get back in here. We're just gonna copy the string from the buffer. Yeah, crackers is preferred. Well, you would save me from the 1 in 10,000 risk probability that I would have tried such a thing. How can this be totally overwritten, dude? When I get a non-ASCII character, I should not be overwriting nothing. $71 and 70 have nothing to do with these numbers. Like they're D090 and D18F. So there's the 90, there's the 8F. So where did the D go? Do I have a problem in my advanced code for UTF-8? And why would it be overridden? So we're losing a byte. Okay, let's look at advance. This is a valid character. We move forward the size of the current character. We count up the number of characters and then we update. So an update. We ask how many bytes is it, and we're getting the correct response of 2. That's fine. 2 byte char modulus d modulus d, or let's go x, which is b0 b1. Image what value. So this is when we build the letter itself. It's not too bad, to be honest. JT, where are you from again? Pacific Northwest, US. I'm from New Jersey. We eat weird stuff here, I guess. I've been in New Jersey once. I've never been to New Jersey. Didn't stay for dinner, but now I know to avoid the spicy fish pizza next time. Can't find it anywhere except my place because I made the mistake of thinking it would be good. But fish and cheese just don't go well at all. Nothing ventured, nothing gained. That is true. Gotta try things. Okay, so there's my D0, there's my 90, and somehow they combine to be something which is not. Okay. Are you ready? And 0xff. Oh, no, not that way. What is B0 and B1? These are bytes. These are bytes. Byte, bit shifted 8, ORed with 1. Okay, what about this then? uint 8t. Because the characters are negative, and it's combining them in a way which is unfortunate. This is just as bad as if I put something like marshmallows in those potato fries they sell at 7-Eleven on the pizza. I mean, I like a lot of things on pizzas. Like I'm no stranger to different sauces, different meats, different cheeses, but you just gotta try to keep it on the meats and cheeses. I'll even do some vegetables. But like, yeah, marshmallows and potatoes, probably not. I don't see that working out well. Okay, so where did we get to on our compilation? I don't know why that's totally overridden, dude, but at least we're getting the right numbers. Okay, so it is getting them. Now it's correct. Okay. So. Clear. Value byte size byte offset byte char offset. Okay. Is overridden. equals other dot is overridden. I bet that fixes it. Okay. Meanwhile, this can be made private again. But it doesn't say it's overridden anymore. I can't do gluten or carbs. Yeah, so I've been known to experiment with some strange pizza recipes. That's true. First thing I ever tried on pizza was French fries or pasta. It's a little odd. I'm gonna start making pizza with eggs, cottage cheese, see what happens. Okay. Yeah, yeah. Okay, these logs all need to go away. Okay. So what other log statements we need to get rid of? Okay. We're just about at the point of having the UTF-8 characters in our output, into our DFA functions. Goes back to here. Okay, 2 byte char, which is probably in here. 2 byte character, go away. Okay. I think this is it. This is the one. Okay, okay. And the goal is that we see that character. Scratch. I want to see this character in my code file for review test parser, which is the output of my current stuff. It's not in here. Shoot. There's our A through Z. Test dot veto. Meaning all those should be fine and valid. I'm just trying to bake egg cottage cheese blend as a pizza crust last week. Yeah, worked pretty good. Best crust alternative I found though is a plain old slice of ham. It's hard to go wrong with a plain old slice of ham. We've tried some egg things as well as bread, or not cottage cheese. There we go. It wasn't bad. I've had worse. There we go. D090, D18F, through Ya, alpha through omega. Boom! We've got UTF-8 characters in our code and non-breaking spaces as well. Nice. And we correctly call out what the letters are. There's A through Ya, alpha through omega. Perfect. Okay, I think that's everything on transitions. Oh, have you added Russian characters? Yes. See right here. So here's ah through ya. This is capital A through lowercase ya. Here is alpha, capital alpha, and lowercase omega. So there's Greek. So we can handle any Unicode now. These are the UTF-8 values of these characters. Boom. Oh, I mean, the rest of the processing hasn't been done, but we are correctly processing UTF-8 strings in our regular expressions. Boom. This may not be a bad time for me to save my work before I break something. Which then brings the question then. Hold on. DFAStates, code snippets, our character reference, if we're in UTF-8. B0. Yep, we need to do it here too. Unit 8T. And there. So let's do a quick build on that to be sure. Yes, our engine will support UTF-8 regular expressions. I love it. Underscore or author yeah underscore. So you can do other things too. If you want me to check other character ranges like Arabic or whatever, whatever. Just have to tell me what the character codes are in UTF-8, or paste the two characters in the range, or something. I can test other character ranges. But I don't know any other alphabet well enough to do that. Just let me know. I'm happy to test. Okay, so, boom, good. Let's see here, journal. Journal. Added notes of optimization flags that are being generated, which we call performance switches. Emitting one method per DFAState. All the conditionals are emitting correctly with no body. Non-ASCII characters are printed on the end of a line, but compared as integers, which is going to be much faster than like a string comparison. What else? Found an issue with UTF-8 ChrRef, both our outputted code and our packed up UTF-8 ChrRef used in the pattern to NFA converter. Type of bytes were char. Fixed to int 8. So text buffers fine, tokenizers fine. That was also updated. Yep. So our code snippets are updated. Our journal, our to do. Oh, did we fix that one though? That is fixed. That's fine. Outputting one method per DFAState. Conditions are all checked. With no bodies. Phew! Do you have to just add A through Z and not hard code every character? Correct. We just check the range. So yeah, if you want me to check characters, I need to know their UTF-8 values. We could also go from Unicode to UTF-8 values without too much effort. But if you want me to check a range, let me know. I mean, I guess I know roughly where katakana and hiragana show up. So we could maybe fake some Japanese testing. Or rather, I know just enough to at least spot the range. But if you want me to check anything other than that, I don't know enough alphabets in the world. There are too many alphabets. Maybe we should just all go to APA. So we could add money symbols. We could add... Of course, I say I can spot some Japanese characters, and I can't off the top of my head. There's the Greek. Probably scrolling too fast. Those all look vaguely Arabic to me. I don't know enough to... Katakana and hiragana in the third 3-byte range? I don't remember. Whoa, 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 stop, mouse. Silly mouse. Okay, wow, that's... I think my mouse is on the way out. I think my wheel is getting stuck. Yeah, I don't know. Okay. Whew. Oops, not that one. Okay, so the other thing we need to do, since we have some functions, even if those functions aren't doing anything just yet, oh, maybe we just finish filling out the functions. So we go to Billy Tokenizer. You can see that we set the rule ID that we're matching. So like we match this \n because of token rule ID. So if we accept anywhere, do we always munch? And this can't accept on a /. Therefore, we don't set the token ID, I think. Or if we're indeterminate. If we get an equals, we go to 8. DFAState rule 8. We can have an equal greater than. Go to state 2, which I think is just the auto accept. Oh. Okay, so if there are no inclusions, we have to just do this. Okay, so the project. Okay, so we're writing a character, we're writing explanations. All of this. It's actually kind of a lot. Although it's much cleaner than the last time I implemented it, so no complaining. I'm thinking we break this up a little bit. I don't think any of that matters. One minute. So we do need that blank back in there. Okay. After this, if we needed explanations, Not sure how I feel about this. There's slightly unexplained behavior here. I said in this region undo, thank you. There we go. I'm a little confused. Why are we doing 2 blinks? Oh, that makes sense. Ends the line, then that's an actual blink. I still don't think this matters, though. I really don't. Test parser. Yeah. Okay. I gotta fill in the body of each of these transitions. I think we're gonna do 2 things real quick. I'm gonna separate this out because it's gonna get even more complicated probably. Right? Let's call it emit. Emit transitions. Okay, now, if state transitions dot size is greater than 0, we emit those things. Otherwise, there's nothing to transition with. If state can accept What does that look like again? Really tokenizer, accept, and break. We don't have to break. Just say that we accept. Because as soon as we accept, we go straight back to the root. So I don't think I have an accept function that I'm emitting yet. We have the rule ID that generated us. Here's where we add our new tokens. And I think it's just going to go back to state 0. So we're going to do that for now, just as a placeholder. Emit transitions. So where we do closing braces. Oh, geez. Okay, we emit that all blank blank. So this blank is basically where the actual processing needs to go. Where we say how to respond. So if we go to our DFAState, the transition tells us what the next state is, tells us what our rule ID and token ID are. Tokenizer contain. Rule ID, token ID, current rule ID, current token ID. Void accept. Which we'll call something, I'm sure. Word accept means different things. Let's not worry about that just now. That's fine. We can have an empty accept. Okay, so that's one thing. What rule ID we were using? Okay. we have to say what token just hit, munch the character, and then state what our next one is. Just grab that. I think this is a common pattern. I think we only save here because we're already in this state. Like we can go from wait a second. Oh, because it's incomplete. This one cannot accept. Okay. If underscore if state can accept let's see, the token role ID equals a thing. Yeah, it's just a number. We'll just do a number with state point two, or no, transition point two something or other. Use the rule ID. Munch. Oh. It's an interesting idea. Oof, this is interesting. Our performance switches. We have the idea of switch dispatching function pointer arrays. What about just a function pointer? Oof, because that could be interesting. Underscore next state equals whatever. We are going to keep using the word root, though. I will explain why when we get there. It's a ways out. Let me think. next state. So one of the things that happens inside of an accept is we do a bunch of stuff, and then we go back to our start state as our next possible state. You have the Tokenizer. Okay. So this is all switch. Something I want in my Tokenizer actually. Near the very top. Like right after this thing. I want to write out an enumeration or pound defines of states. Do it as states. Let's come back to that thought later. Yeah. Ooh, yeah, modulus t transition point 2 DFAState. I think it's called next. Point 2 rule ID. So with this rule we can accept, so if we accept it's on this token ID, we chew up the character. If all that's fine, then our next state is to go to this thing. You don't need another blank line here. Okay, let's try this real quick, and then we'll go back to that other idea. Writer does not name at the top. Transitions was not declared. Okay. Okay, so doesn't leave me BB project. Okay. If I could remember to remove the semicolon. Usually it's the other way around. I forget the fat finger and miss it. It's a semicolon, but not always. Okay, now we're getting close. State ID, I don't remember what it's called, DFAState. State ID, yeah. Okay. DB test parser state 0. Oh, we did not push in. That's fine. We'll figure it out. Munch character next state is 1. We can't accept on any of these, I think. So remember, right, state 0 and 2 can't accept. DFA state 1. I need to get that indent fixed. Set depth 3. 1, 2, 3, 1, 2, 3. Okay, so I need to set depth 4. And then come back out to 3 if we want. Which is the same as a pop. Okay. So just looking at Billy Tokenizer. I do not honestly remember why some of these have a token ID and others do not. We'll have to double check that. Anyway, Munch next state. You know what? Let's just put it in all the time. We just always know what rule we matched for that character. We'll optimize that away later. Remember exactly what I did. Okay, else. So if this state can accept, so where's my else? If state can accept otherwise, we're going to do something else. If defined helper macros and if def helper functions. Okay, in this case, we want to write accept. And in this case, we do that one. Oh, I guess that's the true of this as well. Macros, Munch. Right line. Right line. Right line. Okay. Okay. Where'd that munch go? Munch. Oh. So we munch, we accept. Can't accept, then point to error. Over 30. We're actually getting pretty good progress on this. I keep forgetting that that's just part of my build process now to run the full tests thing. Okay. If we're using helper macros, those are our helper macros. We munch or we munch. If it's a hash mark, it goes to 3. / has to get to a second /. So this is unacceptable. Oh, if the token rule ID is less than 0. Okay. That's how we know. It doesn't equal to 0. Basically, we cannot accept in that state at all. It should end poorly for anybody who tries this test. Okay, token ID 1 / munch and go to 2. So let's go to 2. Should be the second / munch. Go to 7. We cannot accept in this state either, because we have to go / until, so 7 should say if we get a new line character, an end of line character, then we munch that character. Oh, we do not want to munch this character actually. Go to state 7. Oh, if it's not a new line character, we munch it, we go to 7, otherwise we accept. So in other words, if it is equal to these, we accept. Boom, done. So the accept, where's the, is there no error? One of these should have an error. Error, okay. Let me just make line. Yeah, otherwise, this is actually looking about right to me. So see how we're building a state machine where we're going to get a character. Let's go back to rule 0. So when we start our file, we're in rule 0, state 0. We're going to get the first character out of the file. And we're going to say, is it a space? Is it a tab? Is it a non-breaking space? If it is, if we accept, here's the rule that we're going to use to accept. If then we use that character up and say go to state 1, which is here. Now how we get there is what the dispatch is about, but we'll get to that. If it's A through Z, it says, hey, this is state rule 4, munch, we go to state 4, jump there, etc., all the way down to, if we get a character that's not any of these characters, that is an error. That is a failure. Okay. This all looks right to me. All these pound defines are going to be really big pain in the keister to track through, but we will thank ourselves when we do the optimization testing later. Don't think, let's see, can I, in main, one thing I really want project token definition BB tokenizer definition, give me the DFA, log it. Okay. So our DFA, there is no state that just simply accepts, which is fine. We could add one. It might look something like this. Test v tokenizer. Let's get a string. We're going to keep the string. It's going to start with a quote. It's going to contain either anything which is not a quote, or it will contain a backslash followed by anything. That probably needs to be double backslash. And it can contain as much of that as we want, 0 or more. I think that just about ought to do it. There is no hash. It is in there. Well, why would that be? Remember, our tokenizer for our tokenizer definition is crap right now. It thinks the name of a thing is that. That seems a little strange. Okay. Yeah, something about the string thing is breaking fscan or scan. But we can still demonstrate this. Test dot tokenizer. Let's just go with the character instead of quotes. Either anything which is not a quote or a dot. Let's see if that does any better. Maybe it's just double quotes it doesn't like. You shall see. Missing a terminating character. Okay. No, this is good. This was actually something we needed to test. So it did get it, and D7 is an automatic accept. So who goes to 7 is a single quote. That's not quite right. If we get a single quote, go to state 7, where it blindly accepts. The first single quote should not succeed. Oh. So we have an issue still. Maybe I don't have the right number of backspaces, but, well, and this is definitely wrong, so. Project. Right. Char. Else if v equals a quote character, then we have to escape the quote. Probably a backslash quote. Yes, okay. Let's see if that fixes that error. Yes, it does. So VB test parser. DFA root state 0. Okay, so that emitted correctly. Rule 7 munch, and then we go to this next state 7. Otherwise accept. Seven is just an accept state. You know what? Maybe we just simplify our own lives, why don't we? Aren't we emitting in Tokenizer? I'll just make them look the same. It's going to be much easier to read. All right. Simplify where you can. This file's going to get huge as it is. So, our helper macros. Okay. Tokenizer. Sounds fine. This one is fine. Start new token. Okay. Why can't it find start new token? That is a private method. Right there. Because that is private and this is not private, I cannot move the definition of start new token above it. I could declare start new token above it. Oh, not there. Will it let me both declare and define it within the same context? That is a good question. And we went on until the end of the build. Perfect. Oh. Except for this. This is a helper function. Oh. And move all this below helper macros. Okay, I think we're getting there. Just about 5 o'clock. So we have time to get the rule ID, or the state ID. If helper functions. Oh, if def. It is there. Does get a little mind twisty. So that worked fine. Are we defining helper functions in our defines? Helper functions. If I define neither, it will not be happy. It should be happy now. I'm trying to overload it. I'm trying to declare it one place, define it in another. And you're going to be a pill about this. Oh, I don't need to pre-declare it now because it knows about helper functions. Right. It was working, it wasn't. That's because the pound define wasn't in there, so this should be fine. Okay. Set context, start new token. Okay. Accept. Okay. Whew. Okay. Now, we said we want to output stuff here as well, right? Actually, in that same location is probably fine. Well, we can put it in the top. We can put it here. Tokenizer CPP1, 2, and 3 now. There are the 3 segments. To do. But before we do this section, I'm going to go on a short restroom break. and I will be back shortly. Okay. So what we want to do here is write an enumeration of states. So instead of write token methods, write token enum. The project. Write token enum. Don't write state enum. State IDs enum. Which we can actually simplify a bit, giving ourselves the first thing and the last thing. Enum class state IDs there. For Where do I get my DFA from? Right up there. All right. Writer. Oh, we should set depth. A depth of 1, 2, 3, 4. 4, 1, 2, 3, 4. Depth of 3. Set depth of 3. Okay, we're opening a thing, which will be DFA state. Actually, what are we calling our methods? We're calling them DFA root state thing. Okay. Modulus 0, 3D, which is state point 2, state ID. If first equals false, otherwise state ID and first. Don't put out anything, otherwise we put out a comma. Right, state. Oh, come on. I think that's basically it. Okay. Oh, John is off. JTL is off for the night. Have a wonderful weekend. I'll see you next week. Well, see you when I see you. Yeah, you have a good one. Not first. I have to ask if it's last. DFA states at yeah. DFA states size is 1. So if state equals last state, don't put anything otherwise you put a comma. First state goes away, this goes away. Okay, files we keep test parser. State IDs. There's an extra return in there. That's where it came from, so I'll compact it a bit nicely. Even shrink things a tiny bit here. If it's the last one, we give it a bracket and a thing and a new line character. Emitting well-formatted code, I think, is often the harder part of emitting code. Seems like test state IDs. Okay, so that pretty much takes care of that one. Now, oh, interesting. Okay. Set cast to integer, not to integer, to a state ID with a value of 0. Meanwhile, next state has to be a state ID. That was somewhat the point of the whole thing. Oh yeah, project H. Yep. So you can see, we unclutter things quite a bit with our new code line. Test parser, reload, state ID, accept. Perfect. Now, this is wrong. So I'm for next state. Equals Just 03D. That should basically fix that one. Dispatching by switch or by lookup. The concept of accept depends quite a bit on a combination of things. So let's take a look at our performance switches. Ooh, yeah, so many things we can go for here. We're not walking through because it sort of depends on whether we're in lazy or batch processing, how we do even this piece. Helper functions, helper macros. Yeah. We're kind of at the point where we need to dispatch a state and process token stuff. These three are all kind of related, these three to-do items, the way that they interact with each other. Well, this one is done as far as the text buffer is concerned. It's he who uses it that is concerned with it for now. So switch dispatch, token process lazy, process batch. Lazy, process lazy, process batch. So if we do batch processing, we literally say tokenize, and this is just going to run until we run out of characters. So this is a good place to put like a for loop or a for each loop. Which will look very similar. So we can start stubbing that out. We've got time. So we want if def text for each and if def for so this would be the for ChrRef in our context. How much go to context dot buffer? I don't remember what it's called anymore. Class context. Oh. Buffer. Yeah, very good. Roughly like that. Or let's try to start C equals context buffer to, let's see here. What do I even call it? Nice hitter. C dot invalid reason for ChrRef thing, right? Invalid reason not equal to ChrRef invalid reason end of buffer C dot advance. Okay. So make file. Oh, print text for each. Okay. So I'll put that. This lazy one. Lazy is a little harder. Current reason equals thing. M_cur. Where did that get done? Oh. So M_cur is actually current equals M_current M_current. For each. Can I have a for each? Does this M_current? Let's go ahead and remove the warning. Okay. So VB test partition. This is our output file. Rebuild and clean and generate new text into our tokenizer. It did not crash, so for each. And this for each here. So if we're processing a batch, we create two potential forms. One which walks over the the iterator of the buffer, and one which keeps track of the character or cells. So those are both in there. When I set context, I'm doing a thing here. Set context. Start a new token. I think this all needs to go inside somewhere else. Set context should be simplified quite a lot. Only Tokenize sets up a whole new thing. Lazy. Actually, also lets me move this back up above here. Sure. No. Let's put it up here. So we should say void start Are we done? Give me the next token. Start looks like this. Done checks the character. Oh. If process lazy. If the process is lazy, we do this. If we are just doing this tokenizer, we can check that one. Start. Begin is done, and next token. Tokenize initializes some things, throws together a for loop, and then cranks through that for loop, and get tokens should return the result of this. Let's see how that looks. I'm going to start fleshing out the. We're probably going to flesh out the batch one. That's the easier one to think through, I think. So set context should now be a one-liner. Get our list of state IDs, possibly some helper macros, all of our functions there. If you know what. We should declare these all private. Nobody needs to be looking at this stuff. Okay, we'll come back to that. Don't worry about it. If we're lazy, we have a begin, which grabs me my first character. First character. We can ask if we're done, otherwise we get the next token, which is fun. Tokenize, we initialize, we start a loop. That all looks fine. And then get tokens. which is inconsistent with our other names. So let's do that. Begin is done next token. We call this process. Okay, I don't know, something. Oops. Tokenizer. Begin is done. Next token. Process. Tokens. I don't even think I've defined what a token array is. Being optimized out, maybe. Anyway. So we get our for loop. Then how we process depends on a number of things. Okay, so accept is a problem for me. Process. Okay. The easiest thing to conceptualize is inside this batch. Oof, we also need to set m_new state next state equal to. I don't like these static cast state IDs. But I also don't know that oh. You know what? We can use replacements for this. Replacement texts. That's the thing we can do. Let's add that to our to-do list. I'm not sure I'm going to have time to get to it today. Oh, we did that. Just copy this line. Replace with the state ID using backticks. Okay. So I think this shows up several times. Except process lazy, process batch, and then the accept. Okay, that's not what we're worried about, right? Actually, we can do that now. Start state ID. Start state ID by tick. Static cast state ID 0 with this thing 1, 2, 3. Okay. Dot. So section 1 doesn't need it. Section 2 does. Section 3 does. Yep. Basically want that. So where we do write Tokenizer CPP1 right with replacements. We'll need a string for that, which looks something like this. Start state ID. Charge temp 1024 s print f into temp. This string roughly like that. Code snippet 3 gets a similar treatment. This needs to be this. And right with replacements. Oh, yeah. The DFA point 2 start state. Not sure I have the DFA at this point. Okay. That's why we wrote that snippets function in the first place, so we can replace things as we go. Test parser. Accept equals things. Perfect. And this one should show up several times. 4 times, actually. 1, 2, 3, and 4. Okay, so the other thing we were talking about was moving dispatch switch lookup, which happens right before process lazy, which is this one, pop. Okay. We want to make this private, I think. For functions. So this is the ... here. So we actually change things. So section 1, then 2, then 3. Which actually I think simplifies things. VB project. So we write out 1, nothing different there. We write out 2, and I don't think 3 needs this anymore. And token methods happens between 2 and 3. Still. Let's see how that one comes out. I think all the state functions can definitely go at the end of all things. Boom. Oh, can I do an or and an ifdef? Ifdef with or. I just need the or symbol. Okay, so that actually is probably better, BJ. So I would like to remove this space and the one at the end. So new project. Or. This is incorrect. I really need this blank here. Emit DFAState. If we don't do that blank there, we should have to do it here. Last state equals DFA states. Since this is a vector, I should have like a back. Vector. Maybe it's a list. I don't remember. DFA dot. It's a vector, so I should have back, right? It's called back. Dot back. If state not equal to last state. Whoa. Okay. The other was probably succeeding because it didn't matter. Oh, let's see. Huh. Oh, if defined or defined. I see. I forget that if def is a shortcut method kind of thing. Yeah, sure, we're just overwriting it anyways. Oh. Hold the phone. We can't undef these until the very bottom, actually, after all of that mess. undef. Here we go. This has to come in after, well, everything. Pretty sure it's just undef, not undefined. But we aren't running with that flag right now, so it won't matter. Okay, we're getting our warning that we're going to think about wrapping it up. So we should try a build with a couple of different flags set that we think are close to working. Okay, so let's go to make file. Let's do text4. Is that build? Oh. Yeah, we should not define these at all. Okay. So go back to TxtBuff. That's why we test. So in theory, 4 and 4 each should be in the reasonable state soon. I didn't say to. Oh, that's this thing. This will succeed because Iterator is no longer used. Okay, yep, success. What's the other thing we want to test? Make file. So I'm going to go back to for each developer. Macros. Let's see how that goes. Wow, it built and ran. Cool. Or it executed. There's different stages. The one that I care about built and ran. Cool. So that's way better than I thought it was going to be. Let's go back to function. Functions. There we go. We go to our. Oh, this one. Performance switches for each. All 3 files have worked and been done. We do not have any dispatches yet. But we do have process lazy versus process batch. Let's go try that one. We just want to make sure they build at this point. Some warnings. We can fix those up real quick. No return statement. That's actually fair. But we haven't implemented it yet, so that's fine. Okay. I'm willing to accept those errors for now. Makefile, lazy versus batch. This one will complain. Because we've not defined a token array. It does not know what a token array is. Expect this setup before. Okay, so a for each loop literally can't do what I want. That makes me sad. Enter. So I have to say ChrRef C _current equals C. So just token arrays not being defined. So let's. How do I want to do this? Token array. Really just. Oof. Well, let's do this. PV proj. Oh no, we have something called. What did I call it? VV proj parser C. This is the one. If process batch. Now include vector then a tokenizer token array instead be std vector of token array tokens. I mean, whether it's a token or a token pointer, I don't really care at this point. So let's just roll with this. Emitting tons of code. Not even nearly enough though. Like this is the beginnings. This is the start. So let's get those warnings. No return statement. No return statement. Fine. Okay. Maybe test parser. It's a vector of tokens, and that's when we run with process batch. Okay, so we're in for open the library fopen call for each construct. We're using our helpers functions as functions and not macros. Our process is batch processing, so we're gonna blaze through all of the file, get all the tokens into one place, and then you can get that list. As opposed to lazy, where you say, I'm ready for my next token. Both of which have their potential, each combination of which has their potential consequences. Where are we at? Oh, we're at just about 6 o'clock. So, journal DFAState methods are now being emitted with a body stubbed out, except for now, no error handling in DFAStates. Several performance switches have been stubbed in, and so far you compile. Like there's kind of a gray zone we're going to walk through where we're between function, where we're functional and not functional, right? Until a lot of pieces come together, we can't run it end to end. And testing a segment of this process is not trivial until you get it plumbed end to end. So once we get the plumbing all the way through, then we'll be able to actually test. Until then, it's basically compiler and what do I think is going to happen in my brain. Oh, so we've tested several flags now. None of those. The process lazy process batch mostly stubbed in. We're kind of down to the dispatch piece. And obviously, lazy and batch are nowhere near done implementing, but the framework is in place and so forth. Hey, Violet Shades, welcome back. You might know I might as well ask you this question as well. I want to switch to Linux permanently in the future. Which distro do you recommend? Let's see. Hold on. There is in the chat Savage Lord Severus. Earlier there was a guy. He uses a lot of BSD for a simpler, easier system to get started. I would probably go Mint. Ubuntu is pretty full-featured, but I think it's become bloated. Anyone else who has strong opinions, let me know. But I think Mint is a pretty decent distribution. Ubuntu's okay. BSD, if you really want to get into it. Oh, internal static void is still here. Heck yeah. WTake. Okay, internal static void, take it away. Which distro for somebody switching over? Oh, hardware issues, huh? Okay, well, what else you got, internal static void? Ubuntu usually just kind of works, but I feel it's bloated. I suspect BSD is probably a bit heavy to start with, like a lot of technical knowledge required. There's always Raspberry Pi Linux. Virtual machines, yep. You could run it in a virtual machine. Okay, so I'm not far off on Mint. It's been a few years, but I remember not having a bad experience with it. I might even still have it installed somewhere. Been a while. Didn't work on your hardware. That is unfortunate. So yeah, I don't know if that helps. I mean, try Ubuntu. Everybody does Ubuntu. And it's reasonably well supported. Yeah, Ryzen 9 7900 should have been plenty new enough to not be too weird. Pop! OS is also really good. The one, it's like a fork of Ubuntu optimized for gaming. Okay, I haven't actually played with that one. I've used a couple of different Red Hat distros over the years. When I installed Mint exactly following a tutorial, looked it up and said my CPU was too new at the time. Huh. Maybe try again. The kernel writers are usually pretty up to date. I guess how long ago was that? kernel people are usually pretty on top of things. Update your BIOS. Okay. All right. Well, you two hash it out in the comments there. I don't think I want to start down the state dispatching of my virtual machine right now. I think we're actually at a pretty good point to pause. Some reports which have been stubbed in so far do compile. Yeah. Oh wait, did I? Performance switches. Switch function pointer array, straight function pointer, and go to next state is a function pointer, not index. But if you're still super new to Linux, I'd recommend starting off using it in a virtual machine. Yep. No, Linux is a great big beast all on its own. I find that any given tutorial rarely works the first time, and you end up Googling a whole bunch of things along the way. You can buy laptops with Linux pre-installed. Yeah, I would say retry Mint. Mint is probably the best one to start with. If that doesn't work, maybe try Ubuntu. And if either of those don't work, yeah, I don't know where to go otherwise for someone just starting out. Ubuntu. Okay. All right. Okie dokie. Yeah, no, virtual machine. I don't. I've used a lot of Linux in my past in different contexts, but I wouldn't say I'm a Linux guru at all. Certainly not in setting up. I barely Google just enough each time to get my machine up and running, and then I call it good. Okay, so for those who've joined recently, we're writing a compiler. More specifically, we're writing the Tokenizer generator portion of it, and we will for a while because everywhere I think there might be a performance implication, I'm going to generate a #define which toggles that functionality on or off. And then at the end, we will be able to test performance using all of these different combinations in any set of permutations. So like with how you're opening and reading a file. What kind of loop iteration are you doing over the text of the file? How are you dispatching your DFA states? Are we batching our token processing? Are we doing one at a time when requested? Are we implementing our helper functions as functions or as macros? Like these are all things that might impact our performance, perhaps trivially, but certainly worth measuring before we make that determination, right? So I'm going to say file reading is actually done. There's nothing more to be done there. Iteration, I'm not going to call that done just yet because we still have the combination of for each and for inside the lazy branch here. So I'm not going to call that complete. I've stubbed it in places and it works. It compiles. None of those are done. Token processing, the two blocks are stubbed in and compile. That's not really done. Helper functions. I think we have a way that, yeah, that should all be fine. There's nothing more I really need to do there other than when I add a function, add the macro as well. But those are working and compile and should run. So I think this is a good place to pause. I'm running out of time, so far decompile. So our new VB test parser is 1,000 lines. So we generated 1,000 lines, and this is nowhere near complete. So we're gonna pause there for the day, for the week. Monday, back to game development. Monday through Thursday's game development, and then Friday is compilers, so that I get some variety. For those who are new here, I do have a Discord channel where we can have technical discussions. It's pretty quiet in there most of the time. It's pretty quiet most of the time, except for notifications. But feel free to shoot a message in there, and we can discuss offline, or we can address it during stream if it's a good question for that kind of thing. So, yep, Monday we're back on. Thanks for everybody for coming. Thanks for all the comments and chats and discussion. Good luck with your Linux distro, Violet Shades, internal static void. Thanks for the backup there. I'm not a Linux distro pro. Yeah. Everyone have a wonderful weekend. Get some rest. Have some fun, and we will see you all Monday. Bye-bye.